here we consider a practical implementation of the generative adversarial networks. Well, there are two main components in the network, a generator and a discriminator. As we have discussed, the job of the generator is to map from some kind of random distribution into the data space, and hopefully that will let the mapped distribution to be similar to the distribution of the data. So let's call that into capital X space. And the discriminator's job is to distinguish, let me move it here, the samples that has been generated by the generator and the samples from the some real distribution of the data. So here is the X. Say there is some distribution density in the space. Okay, so to design them, we will adopt a two-step training scheme that in one step the generator will work and map some random samples from the what we call Z latent distribution into what we call fake X. And this couple of samples is combined with some real data samples. Let's call them true X. Okay. And we give these two subsamples to the discriminator to form some judgment, and hopefully the discriminator will be able to assign to classify them correctly. Okay, and in this step we train the discriminator, and in the next step the discriminator is used to adjust the generator. So in the next step, still we start from some random samples. We let the random sample to be fed to the generator, and the generator gets some fake X. But in this step, we would like the discriminator to produce label 1 to the generator to the generated samples. But in this step, we do not train the discriminator. We keep it fixed, not training, and we will train the generator. Okay, notice that in this step, the goal is to let the discriminator to produce label 1 or something close to 1 to the generated fake samples, but the adjustment is upon the generator parameters. So here is illustration of this procedure, and we will look at a program design to implement this scheme.